Hello, this is John from caveofprogramming.com, and this is a tutorial on sorted maps and the map interface in Java. And if you've caught any of my previous tutorials, you'll be pleased to know that I've now got a new microphone which hopefully is a bit less hissy than the one that I used to use. So here I am in Eclipse and I've got my main method set up, and in the last tutorial we actually looked at the HashMap class. So let's have a hash map here again, and just like before, I'll make integers the keys. I'll make the keys integers, and I'll make the values strings just because it's simple. And I'll create a variable here, which I'll call hash map, and I'll set that equal to a new hash map like this. So I just need this again. Now the thing about HashMap is it doesn't keep your keys and values in any particular type of order. And if you want to keep your keys and values in some kind of order, there are two really good choices that I know of. And the first one is you can use a linked HashMap. So let's change this to linked HashMap, and I'll call the variable linked HashMap. And a linked hash map is basically just the same as HashMap, except that it has a doubly linked list connecting the entries. And that means that your keys and values stay in the same order that you add them to the map. And incidentally, if you wonder what a hash is exactly, supposing you've got a class that doesn't implement the toString method, so there's no natural string representation of this class here, and supposing you do sysout on an object of that class, so I'll just do new temp here like this. This value here after the @ sign is actually the hash code, and this code is used to store things in the hash map. So that's why it's called a hash code, or that's why HashMap is called a hash map rather. So linked HashMap is the same, except it has a linked list connecting the entries. And there's also a class called TreeMap. In fact, I'll copy this line here, which will save some time. So let's call this TreeMap, and I'll change this to TreeMap. And if you've done any computer science type stuff, you may know that a tree is kind of one of the basic structures in computing, and a tree sorts the values that you add to it, usually in the natural order. And natural order is a closely kind of tightly defined concept in Java, which we'll look at in future tutorials. But basically the natural order is just what you'd expect. So for integers, natural order is 1, 2, 3, 4, 5, and for strings the natural order is alphabetical order. And you can define a natural order for your own classes, but we'll get into that in a future tutorial. So here I've got three kinds of maps, and now I want to create a method that's just going to demonstrate the difference between the three. So I'll make this public static void test map, and all the collections in the collection classes in Java are organized under various interfaces, and the three that spring to mind, I'm not sure if they're the only three. Well, actually they're certainly not the only three, but perhaps the main three are list, which we've seen already in a previous tutorial, map, and the set interface, which we're going to look at in the next tutorial. So these maps all implement the map interface. So if you want to pass them to a method, you can just use the type map like this. I have to also put the parameter types in. So I'll just call this map. And the map interface has the kind of all the methods you need for manipulating your map. So let's start by adding some values to this map that I'm going to pass in. I'll just do Ctrl-Shift-O add the import again. And one of the most important methods of a map, of course, is the put method, which we saw in the last tutorial. So here, let's add in. I'll put in some numbers, and I'm going to sort of make them pretty random. And let's have just like the names of some animals here, like this. And I'm going to add a few more of these, so I'll just copy this line. And I'm going to put some random values in here. So let's say 4, 8, 1, 0. Let's have maybe 15 and 6. So just all mixed up. And I'll put some animals in here. Giraffe, swan. What other kinds of animals are there? Bear and snake. Okay, and I want to show you also in the last tutorial we looked at one way of iterating through maps. That's probably the most efficient way, but I want to show you another way here that also works pretty well too. So you can use a normal kind of for each loop to iterate through a map, and what you can do is you can actually iterate over the keys and then use the keys to get the values. So the keys in this map are going to be of type integer. So I declare a integer variable here to iterate over the values of the keys, and I'll call it key. And then I'll put in a colon, just like in a normal kind of for each loop in Java. And then I can say map.keyset to actually get the set of keys. And map.keyset actually returns a collection called a set, which, as I think I mentioned, is going to be the subject of the next tutorial. But basically, all you need to know here is that you can iterate over a set using these kinds of loops, as you can with many of the collections classes. So having got the key, I can easily get the value, and the value is of type string. So I can say string value equals map.get and pass it the key, and that will get me the value. And then I can do sysout key, so a plus and a colon and value, like that. So the point of this is now I can pass in any of these maps. I could say test map, hash map, and if I run that, it's outputting the contents of my hash map. And actually it so happens that in this hash map the keys have ended up in numerical order, which is pretty common, but it's not guaranteed. So absolutely do not rely on it, because sometimes they will come out in some sort of an order, but other times they won't. There's no guaranteed order to hash map. And one thing I can also do here is in the collections classes, so you've got the kind of main interface types are list, map and set, and depending on your taste really, you might want to use the kind of interface type with your collection objects wherever you refer to them, except when you create them. And that's kind of whether that's clearer or not is kind of a matter of opinion, but the kind of logic behind this is that say for example you open a bank account. When you open the bank account, you kind of maybe do some research on the bank and you find out how the bank works, what interest rates they offer, what kind of accounts they have, that kind of thing. But afterwards you don't really worry about what particular bank you're with. You just think about the interface of the bank. The interface of the bank is stuff like the cash machines that they have, the counter services, and you expect these interface, the kind of interface, to be kind of basically common to all banks. So it's a kind of similar thinking here. You can, when you actually create your map, you've got to worry about, or your collection, you've got to worry about what particular kind class it is and whether it fits your purpose or not. But afterwards, you're just dealing with it using kind of common, in this case, map methods. So you can, if you want, you can forget about the exact type, hash map or whatever afterwards and just deal with variables of type map. But that's kind of your choice. So hash map doesn't guarantee any particular order, even if it sometimes appears to be an order, which it often will. Whereas linked hash map, as I say, it maintains the order that you put things in. So if I run this, you can see that this order that things are coming out in is going to be the same as the order I put them in here. And tree map is going to sort the keys in their natural order. So if I run this, the tree map's going to put the keys all in order like this. And in a future tutorial, we're going to look at the concept of natural ordering a bit more and see how you can define it for your own classes. But that's enough for now. So the next tutorial is going to be on sets. So join me again for that. I'm going to put this code on caveofprogramming.com so you can take a look at it if you want to. And until next time, happy coding.